Hello, friends. Welcome to another episode of Archit Jain podcast. So, we are talking about technology is not going on, but the technology that is of about future. So, the name of technology is more about quantum computing. So, the quantum computing is the future of technology. Fancy. After 10 years, the impact is so much high. Just like the artificial intelligence is right now is a trending one. Just like that, quantum computing is for the future. So today we invited one of the guests from Microsoft India. So she's Salaka Verma. So Salaka is right now working as a director in Microsoft. So hi Salaka, welcome to the podcast. So yeah, Salaka, could you
Hello.
tell us little bit
Thank
about
you for
your
inviting
so
me.
our audience also aware about you?
Sure. Um, so I currently lead the customer success for banking and financial services industry at Microsoft. As part of this role, I'm responsible for making sure that all the technologies and platforms are best utilized and our customers get the right kind of value out of the
Yes.
investments that they are making with Microsoft. I carry about 22 years of industry experience, 3 years in Microsoft. Before that, I was in IBM for about 10 years. And then about 5 years I spent in startup and about 5 years in
Yes.
Baba Atomic Research Center as a computer scientist. I carried the passion for quantum right from my early career when I was doing Baba Atomic Research Center work. And then I picked it up again in IBM towards 2017
Yes.
18 and have been active in the Indian ecosystem
Yeah.
and carried the passion
So,
forward in Microsoft as well.
before moving towards discussing about quantum computing with our guest, so I would like to tell about why this podcast is important for the viewers and for the anyone who would like to tune this podcast. So basically, the quantum computing, the trend is coming from the 2019. After there's a big change in this quantum computing. Some companies claim they are quantum energized. So then afterward, this term is going on the trends. Okay. So even if you are preparing for UPSC, even if you are preparing for anything, even if you are tech savvy, even you are working for an IT company, even you are in product management, whatever role you are describing. So this concept is necessary for your growth as well as for your personal growth as well as for the professional experience. So let's get started. So Salaka, could you tell us about what is quantum computing? How this quantum computing? Yes.
So it's very important for us to understand that it is not just a new
Yeah.
server
Yeah.
or a new fancy gadget on the block, right? Uh, Quantum computing fundamentally changes the way computers are built. Just to give you a very small example, right? Today, everything that we compute, like all the classical computing, is fundamentally based on the voltage pattern at probably 0 or 2.505 volts, which we call
Yes.
as, we sort of abstract it as
Yes.
0 and 1. And then everything that we do is on top of that 0 and 1, right? Now, in quantum computing, our fundamental building block, right now, what I explained to you is bit, but our fundamental building block is a qubit. And qubit, in principle, has the property that it doesn't really have to be in either 0 or 1, but it can be in both the states simultaneously. It leverages a quantum mechanics principle called as quantum superposition, and that allows this particle to be in both the states simultaneously. So it is inherently a very new way of computing. Most of the time, this computing is going to be probabilistic because the state of the qubit is either 0 or 1 is a probabilistic state, right? Now, because of this new way of computing, it unleashes very different ways of solutions that are otherwise not possible in the classical computing. So the current right advantage of quantum computing is not about just processing something faster or improving latency for something, but really solving the problems that are otherwise not solvable or have very approximate or crude solutions in the current method of computations. Right? That's really the promise of the quantum computing. And the building block of quantum computers are qubits, and they are fundamentally based on quantum
great.
principles of
So,
quantum superposition
Salaka,
and quantum. It's going to be harder to explain in words. There is a very famous saying in quantum computing that basically means that if you want to understand quantum, you need to shut up and start calculating, because it's easier to understand quantum mathematically rather than trying to understand by capturing it in words. But I'm going to attempt to sort of let you know how that works here, right? Now, like I called out in our current way of building the computers, we have got so used to creating these transistors which can be in 0 and 1 state. Similarly, in the quantum world, in the quantum computing world, a qubit can be created by multiple methodologies. The one that is most successful right now is the supercomputing based qubit, which that basically means is you are having a superconductor. Superconductor is basically a conductor with zero resistance and infinite current can pass through that, right? A superconductor in which you are trying to introduce a very small Josephson junction for resistance, and then you are then the current that flows through the leakage current that flows through that has an ability to behave like an artificial atom, and that is your quantum qubit in the quantum computing, which are so the supercomputing based quantum computers are seem to be most proliferated. IBM has built one, Google is trying to build one, and so on and so forth. But there are other methodologies. But the second one that seems to be picking up is the trapped ion, which is what Honeywell is pursuing and IonQ is pursuing. Then there are attempts right now happening to create a photon-based quantum computer. Photon is by far the most difficult particle to control for the quantum behavior, but it is also a good attempt, I would say, because photon is also the only particle that can show quantum behavior at ambient temperature. All other machines would need very cold, like near zero, absolute zero space, lower than the outer space kind of temperatures to really show or display their quantum behavior. So photon from that sense has a big potential. And of course, Microsoft is trying to attempt topological qubits, which is Majorana based. Again, this is a great breakthrough if it really happens. At this point, this looks very difficult. But I think that Microsoft research is very, very convinced that they will be able to get to a computer which is Majorana based. Again, the advantage is really going to be more stable, more scalable qubits than that is possible with, say, a trapped ion or a superconducting qubits at this point, right? So, different ways of creating a qubit, but at the end of the day, once a qubit is formed, you are going to use the quantum principles of interference and the quantum principle of superposition to try and do computation on top. And all of these computations are going to work on abstracted qubit, so that all the logic that you build on top of that, like a software logic that you're trying to build or the algorithm that you're trying to build, should operate and work irrespective of the actual hardware methodology that is used to build a quantum qubit. So everything else is on with an abstraction. I think industry is coming together to define the gates, which are basic building blocks. Some algorithms that are pre-ready or pre-canned now. Qiskit, Microsoft is using a language called as QDK. IBM using a language called as Qiskit. A lot of them seem to be pivoted on Python to make it very easy for people who are already doing Python and so on and so forth, right? So really it's going to be a different way of creating a machine and a different way of writing the code, and then the different way of running the code. So rather than running it only on quantum,
as you told about the
on
qubits
hybrid
and
machines
these
and
things
so
are
on.
so much
So that's how
these
state of the art looks like at
and
this
what
point.
Microsoft is using and IBM is using. But from this, what are the potential applications for the quantum computing?
Um,
Yes.
So think about Netflix today. And think about internet 20 years back, right? When that internet was born, did any of us really think about Netflix? And we did not, right? And quantum can be a game changer like this. So I don't think we really have visibility of what is actually going to be possible when these machines are available. But early motivation to build these machines comes from a bunch of problems where we think a solution may be possible and can be game changing. Now, one of that use case is really on the chemical simulations, because most of the simulators, so we try and find new materials, new chemical reactions, new drugs, and so on and so forth by doing a lot of chemical simulation. And the chemistry or the way the two atoms interact with each other fundamentally is quantum mechanical. So whatever we do, whatever experiments we do, we are not able to simulate them accurately on classical machines, because classical machines do not work on quantum principles. So that is the first motivation, right? Can we create? So I'll just sort of give you a very small example of, say, a nitrogen fixation, right? We use nitrogen in all our fertilizers. It's in principle required for us to feed our civilization, all our people on the planet. So we use fertilizer a lot. And for fertilizers for creating the ammonia, currently the way we understand creating the ammonia is a high temperature, high pressure reaction. We use 7-8% of global electricity just to produce ammonia that can go into our fertilizers that can feed us eventually. But we know earthworms, we know those creatures create ammonia in the soil at the room temperature at ambient pressure. So we definitely know that it is possible. We don't know how, because we are not able to simulate, we are not able to experiment. So just by getting this one thing right, you're probably going to save 7-8% of global electricity that can actually light up the entire globe that is right now not having access to electricity, right? So that's the potential. And then it can make your crop and fertilizers so cheap that your food sort of becomes cheaper and cheaper, and that also saves or serves a lot of people on our planet. So just one example, you see the potential that can be really game changing. Similarly, similar situation is going to be in the drug discovery. Are you able to find the right kind of drugs faster? Are we able to sort of cure the diseases that otherwise seem incurable right now, right? So those are again big shot problems that we could attend just by getting the chemical simulation right. It can eventually lead to a lot of manufacturing optimization, processes getting streamlined. I was a couple of days back reading about quantum superchemistry. Looks like quantum superchemistry also can be simulated well on quantum computers, and eventually that can take the manufacturing costs down. It can serve our sustainability objectives. It can eventually reduce your carbon footprint. So there's just a lot of goodness by just doing chemical simulations right. If you are sort of reading through, then Microsoft recently launched something called as Microsoft Azure Quantum Elements that actually helps us speed up the chemical simulation processes and their quantum formation, etc. Right? So I think that is one big umbrella of the use cases that we could potentially look at. The second one I see as mostly the optimization problems, and optimization problems again do not have a easy path. Lot of times these solutions are approximate, and it is very difficult to prove that this is not the most optimal solution. And hence we probably live with what we have, but there is probably a scope for optimization, right? And then optimization problems are proliferating all over. Like we use optimization in banking industry to find out fraud, to detect the pattern, or even from our investment perspective, the way our portfolios are optimized, given our constraint of risk and benefit that we want. That's the same problem, or the similar construct of the problem can be applied in manufacturing, where you think about, say, supply chain optimization, traffic route optimization, cargo optimizations, flight optimizations, right? So I think the the larger umbrella of the problem that we could solve potentially is the optimization, and then it would go across industries.
Correct.
And every industry will have some or the other nugget. Like
So,
in the telco, you could have bandwidth optimization.
as you
right?
told
So
about
everywhere
these
you can
formation
find the use
Azure
cases on
elements as well.
how the
So,
optimization
as we
problems can
develop
help
and
you
doing these
create
types
a
of
net
quantum computing,
benefit.
so always there
Either
is
to
a
your top line
challenge.
or a
Challenge is always
based on the
associated.
industry.
Even we are doing anything, even if we are doing a cooking as well as writing and anything we are doing, okay, in general as well as, so there are always a challenges associated with that. Okay. So what are the challenges of quantum computing in current and present era?
I think the challenges are many. The quantum computing is not necessarily right now what you term as only an engineering problem, right? It
Correct.
continues to be a
Correct.
research and engineering problem. So what we have created is a near intermediate scale
Correct.
noisy quantum computers that gives us peek insight into a peek of the future, what's possible, where can we go, and so on and so forth. It also has given us a path to create what is required from the software stack perspective. It has also given us pretty good insights about what kind of workforce do we need, what kind of skills need to be built. But all of this work has to happen, right? We have to have, we have to skill people, and we need to sort of get them going in terms of building solutions. We need to get the error correction and the stability of the quantum machine right so that the production scale problems run on that. And we also need to have the large scale quantum computers which can make sense to really deploy the real world use cases at a scale and at a speed that we need them to execute on, right? So, and the work has to happen across all three. So, creating the machine itself, writing the software stack and the algorithms on which solutions can be built, and then creating the workforce who can help us build the solutions. And the challenges are on all three pillars to get going, to move forward, and so on and so forth. Different kind of challenges, but they are everywhere, and hence there is a opportunity for the young entrepreneurs to sort of
So
just
how
dive
we
in
goes
and
towards the quantum computing?
pick up a problem and
present
attempt to solve it one at a time. Yes. So we are there in terms of getting the prototypes and POCs out, creating the use cases, curate the scenarios, figure out what we want to pursue as a top solution, as an industry, as a customer, as an organization, right? So we are there. That kind of ecosystem readiness is there, but we are not. But we are far away from really having a fully fault tolerant quantum computer. Um, Everyone is picking up different name for that. I think Microsoft is saying quantum supercomputer. IBM is saying fault tolerant quantum machine. Everyone has a different name for that end goal. But I think we are far away from there because we simply need to get everything right. So we don't have the right kind of scale on the machine level. We don't have the right kind of stacks that are scaling, and we don't have enough workforce to make a full-scale commercialization of the quantum computers at this point. So probably, I think 7-8 years away. But work has to start now because the entry, barrier to entry is also pretty high in this field, right? So we are a bit away, I would say, in terms of really having a commercial, full quantum machine-based economy. What is near is the work that needs to happen on the security side, right? Because a fully fault-tolerant quantum computer, whenever that appears, would actually break the RSA algorithm that we use currently. And we are encrypting everything via RSA. All our banking transactions, all our assets, all our digital identities, everything, all our payments, everything that we do today is secured via RSA, and RSA will break when a fully fault-tolerant quantum computer is available. So, pretty much anyone could actually just take the data now and keep it in the cold storage for next 7-8 years and start relooking at that, right? When it's really broken. And hence the time to sort of start protecting that kind of exposures, which you don't want
I would like
to be out there, say 8-9 years down the line.
fault tolerance is a concept that is
the
used
work
so
that
much
needs to
properly in the
happen to
computing.
protect
So
the
fault
assets
tolerance
needs
is
to
simply
start
saying
now.
if I
And
put up
I
a
think
one
that
resource,
is like
if it is not
immediate
working, so
need
there is a
of the hour of
alternative
the
resource can
industry.
work on the place of them, and there is a no redundancies there. Ki user can impact about that. So this is all about fault tolerance. So, for example, if I give a very good example as well, right now, the camera what that is recording this podcast. Okay, if it is not working, so there is a one alternative camera that can do that job. Okay, and I did not feel that. So, Salaka, ethical. What are the ethical implications of quantum computing?
See a lot of ethical problems in quantum computing. See,
Yeah.
the ethics really start to matter a lot in the technologies like generative AI, or even AI at a larger term when somebody tries to take decision on behalf of a
Correct.
human being, right? That's where a lot of ethical considerations start to come in the picture. Quantum computing is not about ethics. Quantum computing is really a different way of computing. Like you have a calculator to do additions, you are going to have a different kind of computer to do different kind of mathematics, like a simulation. But it is not going to decide on our behalf. And hence, I don't think that there are going to be lot of ethical implications on using quantum.
So, always there is a risk. Yeah. So, Salaka, what do you think, according to are the biggest risk associated with quantum?
There are many, I would say, at this point, Archit.
Yeah.
The first one is the ability to really get to the fault tolerant quantum machines
Yes.
in the time period that we are projecting, which is 5 to 6 years from now, right? So getting to those research breakthroughs and our ability to, or the risk that we carry that it may not happen is a genuine risk
Yeah.
for us to move forward.
Yeah.
The second one is really the proliferation of the stack, the kind of work that needs to happen for the algorithms to get built or the net new solutions to sort of spawn is humongous.
Yes.
And our ability to do it in a way where it sort of remains commercially viable for people to run their large scale problems on the quantum computer whenever those computers are available. I think that is the second risk that we carry. It's also an opportunity, I would say, the one of the biggest opportunity that I see in this space. The third one is the risk on the security side, while we are trying to attempt and assess the risk exposure and then come up with a bunch of new security protocols that look quantum safe for now. The execution is going to be a big risk because we have taken so much time to even to get to our RSA proliferated to the extent that we now have. If we continue to have this kind of time lag in our security protocol adoption, then that's one of the biggest risks that we carry, and it can shake the faith of everything that we are building right now digitally. Both the healthcare, the finance, the manufacturing practices, everything can come under risk if we don't if we don't stay ahead of the risk that the quantum will bring in for the security and fix it, with a sense of urgency.
So the every technology can change the world from their perspective. For example, if AI comes, so AI application ChatGPT can change the experience of the users of doing the work. Okay, like Adobe Podcast and Adobe Firefly can change the way of editing the things. Okay, how quantum computing can change the world? Okay, like iPhone can change the world of mobile experience. Microsoft can change the world of the how we are using the laptops and computers and desktops. So, quantum computing changed the world.
So, quantum computing will actually impact everything that we know in terms of the complex problems solving. And the complex problems exist across industries, like I've called out, right? It has a huge potential to change the way
Correct. Yeah.
we feed our population. It can create a huge impact in drug discoveries and getting to the precision medication faster. it can have a huge impact in the automobile space, not just in terms of figuring out the right kind of
Correct.
paints, coating, coloring that can make autonomous vehicle a more like a reality, but also about navigation, right? It can have a huge impact on how the supply chains are optimized, and hence the cost of goods in general can drop drastically. Uh, it can do wonders for improving the quality of life that people live, the earning potential that people have, and uh, also the cost of living that we incur today, right? So I think the way quantum computing will impact, it will end up impacting every industry for bettering an outcome. It is either going to be about solving a problem that is unsolved so far, or reduce the cost of something that we are already consuming, or finding an efficient way of doing something. And in the end, because we all are consumers of those industries, it will end up impacting every life eventually.
So, what? How will quantum computing impacts our life in the future as well as the today?
Which is what I think we have been talking about it. All the use cases that I called out, that's the impact. So essentially, the impact is really as an individual, right? As a consumer of those technologies, I think the impact is really going to be about better healthcare, better access to food, better insights into our health parameters and how are they correlated into some diseases and nutrition information. Better banking services, better potential to maximize the gains against the investment that we are making, better access to more sustainable goods in general. I think that impact is humongous, and it can, that future promise is absolutely there. Today, all of this can pretty much get into prototype and
till now, as you discovered and you are also in this field of the quantum computing, till now, is it defined different types of quantum computing?
Different types of quantum computing, but what I just called out, right? There are different ways of creating the qubit. And those are, so you could call them pretty much like different morphologies. And then there are two types of machines that are currently getting created. The one which is like circuit-based quantum computing, which uses the quantum mechanics principles of inference and superposition. And the other one is, it uses the principle of superposition, inference, and quantum entanglement. And the other one is more like a adiabatic processing, which D-Wave does, where they still use quantum superposition and quantum interference, but they do not use quantum entanglement. Right? So those are largely two types of machines that we are seeing. D-Wave seems to be having a higher scale, but not necessarily the breakthroughs that can.
So, as the Google in 2019 told about, they are solving some of the problem of that is not solved by the supercomputer as well as the world biggest supercomputer as well as that is owned by the IBM. Okay, in 2019, according to the facts. So, what are the other problems apart from the mathematical problems are solved by the
quantum is a computing machine, right? Quantum computer is a computing machine. It will solve a mathematical problem. The question is where all these mathematical problems are getting used today, right? Because a lot of these things are hidden. Like for example, a simple things like matrix inversion is used across almost all optimization problem, like supply chain optimization, traffic route optimization, and use it in portfolio optimization, and so on and so forth. So quantum computer will still solve a mathematical problem, but the applications of those mathematical solutions are humongous. And that's what the industry use cases are about.
So, as we always set a milestone to achieving something in our life, career. So, what about the next milestone for the quantum computing in the Microsoft or in the industry?
So the next milestone is really going to be about having a fault-tolerant quantum computer backed by the proliferation of the algorithms and a skilled workforce to support the use case development. I think that's really going to be the next milestone. The the milestone that we were defining 2 to 3 years back was really the intermediate scale noisy quantum computers with capabilities to build right kind of prototypes and POCs with a core skilled team across industries. And I think we are there already. Microsoft seems to be making a lot of stuff democratic by making different kind of quantum machines accessible on Azure quantum platform directly, and also supporting different kind of languages like QDK, Qiskit, and Forest, and so on and so forth, so that people with all kind of affinities can come together and still have a single place to explore quantum computing in general, right? IBM did their bit to democratize quantum machines. They were the first on the block to have the noisy intermediate scale quantum computers, but they made it directly available via IBM Cloud for free for people to experiment. And in a world where you really don't know what you are building till you actually run it on a quantum computer, the access to the quantum machine is a big deal. So I think that help was also tremendous in terms of
Salaka, is there any something that I missed out in this podcast that you think that need to be covered? So you are feel free to.
I think what we are missing is the call to action. Those who are listening to this podcast, I would definitely like them to explore quantum computing, get started. Lot of courses on LinkedIn. IBM has a free path. Microsoft has a free path. Just getting hands dirty, getting very curious about the technology and the applications, and making sure that you understand and you are ready when it's already there, can do wonders both for the industry in terms of progressing the motion forward, but also you as an individual.
So I think I missed something. What is your success mantra? To be, because you are not at a position, you are at a position that really impact the billions of users, the Microsoft. So that's why I'm asking, what's your success mantra till now?
As an individual, my success is really about me always doing what I like the most, but then doing it with a strict adherence to a lot of excellence, depth, always having a growth mindset, which means I am almost always learning and experimenting with the new things. And that comes when you are resilient and you are always embracing discomfort, right? So that pretty much sort of sums up how I have navigated my career in general, Archit. But for the quantum field, the way I am defining the North Star is an ability to have at least one use case in each industry that has created a breakthrough and has given us a quantum advantage that will impact lot many lives meaningfully in at least next one decade.
What one habit you are using and utilizing in your day-to-day life to being a successful? Because woman in tech is always defined by people like you. Like it's always a woman in tech. So, and the brain plus beauty is always defined via people like you, like via Salaka Verma type of people. So yeah, Salaka, what one habit can define you in your life that can change the way you are living?
I learn every day, folks. I mean, that has been my core companion through my entire journey. Learn something every day and be very intentional about it, and always reflect upon what you have learned. I think every small thing that you learn eventually connects, and that helps us unleash and leverage larger and more complex problems and opportunities as they open up in front of you. So that's I think it's that simple. And while learning, just have fun all the way. I don't focus on how will I use my learning tomorrow and day after sometime. future, right?
So thank you
Have
so much,
fun while
Salaka, for
learning
this
and
podcast,
learn
for
every
giving
day.
your valuable time. Okay, and the way you are explaining the quantum computing is really impacting the users, and I hope and my best wishes to for you and as well as for your company Microsoft to being innovative always. So and yeah, thank you so much, Salaka, for giving your time and for the beauty plus brain plus woman in tech.
Archit, for inviting me to the podcast.